Okay, so welcome back. And so what we're going to do today is we're going to do one last example for this section on variation, and this is on combined variation. So now we're going to combine different variations in the same problem, okay, and show you how those 4 steps will help you solve the problem, okay. So again, it's just those 4 steps. So again, let's read the problem carefully so we understand what's going on. It says the number of vibrations per second, pitch, of a steel guitar string varies directly. So let's highlight this. So what the pitch, right? So vibrations per second, right? Pitch varies directly as what? As the square root of the tension in the string, okay? And it varies inversely as the length of the string. Okay? So there's 2 things going on. Okay? So let's, again, when it comes to combined variation, what you want to do is you want to piece it together step by step. So we're going to take one variation and then we're going to add the other variation piece to it, and you'll see how this works. Okay? So let's take the first one. So we know that the pitch varies directly as the square root of the tension. So let's give these these letters. So we'll call it vibrations per second pitch. We'll call that P. We'll represent that with P. We'll use T for tension. Okay? And we'll use L for length. Okay? So let's take this piece by piece. So we know that the pitch varies directly as the square root of the tension. So let's do that piece. Okay, so we know that P varies directly as the square root. So directly means it's going to be, again, it's going to be of this form. Y equals kx, right? So now we're going to write P equals k times what? The square root of the tension. Okay? Now we're done with that piece. Now it says, but it also says, and the pitch varies inversely, right? So the pitch varies inversely, so now we know it has to have this form, right? Well, we've already got K here, so we know P varies inversely, so that means something's going to go on the bottom. Well, what's that going to be? It's going to be the length. And that's it, we're done. There's our relationship. This is what we call combined variation. So P, the pitch, varies directly with the square root of the tension, but inversely with the length of the string. Okay? So all we did was we put these 2 together in one relationship here. Just looking at the wording of the problem. Okay? So now, what's the next step? We've got to use the information they've given us in the problem to solve for K. Okay? So let's do that. Well, what's P? It says, if the pitch is 50 vibrations per second. Okay, let's put that in there. Then we know that the tension, okay, so if the pitch is 50 vibrations per second when the tension is 225 newtons, okay, so that's the tension, so we're going to put 225 newtons here, divided by, and the length is 0.6 meters. Okay? Let me do this here. Okay, so now we've got the information they gave us, and now we're going to solve for K. So now what I'm going to do is I'm going to just solve for K. So K equals what? It's going to be 50 times 0.6 divided by the square root of 225. Now, if you notice something, again, this is just, be careful. So, the square root of 225 is 15. So, if you don't know that, that's fine, use your calculator, but 15 squared is 225. So, this is going to give us 50 times 0.6 divided by 15. Okay, and 5 goes here, and 5 goes here. Okay, so this is, okay, great. So now this is going to be easy. So this is going to give us 10 times 0.6 is 6 divided by 3, which equals 2. So K is going to be 2. Okay? Okay, so now that we got K, guess what? Now we've got our formula. Our formula is P equals 2 times the square root of the tension divided by the length. And now we can solve, because now what they're saying is, hey, find the pitch when the tension is 196 newtons and the length is 0.65. So now all we have to do is plug and chug. So this is going to be 2, oh, hold on, so we're going to do 2 times the square root of 196 divided by the length, which is 0.65. Okay. And so, is this a perfect square? I'm thinking it is, yeah, it's 14. So, the square root of 196 is 14, which gives us 2 times 14 over 0.65. Which is going to give us 28 over 0.65. Which I don't have a calculator. That one I can't do in my head. Sure we can, why not? So 65 divided by 2800. So this is going to be more than 25. So it'll be less than double. So this is going to be 260. So this is going to be 4, which is going to give us 200. So 3, so 2, 130, 195. So that'll be 3. So 195, which gives us 5. And so that'll be 50, so 0.03, so 500. And that's going to give us 260. So 7. So that's, yeah, 7. So 7 times 65, so 7 times 60. 7 times 60 is 420, plus 35. So 430, so 465. And that gives us 45. So approximately, P is going to be approximately 43 vibrations per second. And that's it. Again, use your calculator. Don't use long division if you don't have to, but I didn't have my calculator, so hey, I can do it. Okay, that's it. So again, this is an example of using combined variation, and practice this. If you have any questions, reach out to me. And but again, do this on your own. Make sure you can get the correct answer. And if you don't, just ask, or see where you're making your mistake at. But try to do it without looking at the solution first. Do other problems. Practice these. That's how you're going to get good at these. Other than that, have a great day.